Cool. So, from last week, we said that everyone should have a copy of CAP Form 110 and a pen in front of them for this week. So, if you do not have that, please try and go print that out as quickly as possible, because we will be logging things throughout the session today. Yes. So we have some slides that we will have that you will base your logs off of, and we'll see how that goes. At the end of the class, you'll be submitting those logs to me via email, and I will grade them based on how clear they are and if I can read your handwriting. So a little more on that later. But here's an overview of what we are going to be covering today. Please do not enter these task numbers yet, but they are there for your reference. So we're going to go over logging, converting grid, true, and magnetic azimuths, round number 2. We noticed a lot of you guys did not do so hot on that quiz, so we will be going over that again. Then measuring distance on a map, determining and plotting azimuths on a map, and orienting a map using to the ground using terrain association. We actually do not have other useful topics, because those will all be covered in the quiz, which you can just go and take yourself. That quiz will not be graded for pass or fail, but it's just for your information. So, logging. You guys might be wondering why we want to keep paper logs in this day and age. We can just enter things into Wimmers or use Google Docs or do something like that that can make our lives a lot easier. But the Ground and UDF Task Guide basically tells us that logs have to be kept for a variety of reasons. And the reason we want to keep paper logs is what happens when you lose internet connection and can't connect to Wimmers or Google Docs or whatever else you may use. What if your cell phone battery dies? What if there's limited generator power and you can't power an extra computer for logging things? Basically, our conclusion is a paper log will not run out of power, be sensitive to connection issues, or depend on complicated electronics. So, here's some general guidelines for logging. When you are writing on a paper log, you need to make sure you write legibly. If block letters are appropriate, please use them. That means if that makes your handwriting clearer, please use the block letters or capital letters, uppercase letters. Please make sure you're brief and concise, but also complete. We want to log all the information that is pertinent, but we don't want to be reading an essay every time we look through a log. When writing dates, you want to use commonly understood date formats. So 2020-07-13, that's 2020 July 13th, or 13 July 20, or 13 July 2020. They are all good formats. When people start writing logs as 7/13/20, then there may be confusion because different people write dates different ways. But if you write the dates in these 3 formats, there will be no confusion as to what date you're trying to specify. For the time format, always use 24-hour time or military time, as some people may call it. There's no 7 p.m. So right now in Illinois, it is 1909. So do not write 7:09 p.m. Sometimes it may be appropriate to use Zulu time, otherwise called Greenwich Mean Time or Universal Time Coordinated. That is the time zone going right over England, Great Britain, all that location over there. And the reason we use that is sometimes if we have an incident that spans across multiple time zones, then I won't be writing in mountain time on my log, and you won't be writing on central time in your log. We will all be on the one common time zone. That also means that you need to know the offset for your time zone in relation to Zulu time. And this actually changes with summertime and regular time. So please make sure you know that going forward. Local time, if you're writing in local time on your logs, make sure you specify what time zone you are in. So the first entry of every log, if you're writing in local time, should specify, for example, right now, would be 1910 CDT. That's for you guys in Central Time. There's a common format that people like to use.
Felix, let me interrupt. I noticed we've got people from the East in Florida and that, so I don't want to confuse them. We got all kinds of people from all over the country.
Yes, so that's why I said CDT. So right now, Central Daylight Time, CDT is UTC -5. That's Zulu time -5. And if you're on the East Coast and Eastern Daylight Time, that's UTC -4. And for me in Mountain Time, it's UTC -6. So regardless of where we are, the current Zulu time is 12:11 a.m. or 0011 in terms of military time. So that right there already demonstrates why it is important to note down the time zone. There's a commonly used format. People like to say Lima time. Oh, it's 1811 Lima. It's 1911 Lima. Lima is actually a specific time zone. It does not really designate local time. So you may see the letter Lima after time zones or after times that people write. And a lot of people will say, oh, that is local time. But no, that is actually a time zone that goes over Papua New Guinea and parts of Russia and way over there in the Pacific. So for the sake of correctness, please refrain from using the L afterwards. I see a question here. Should you write in complete sentences on your logs? Write how it will get the message across. So if you must write in complete sentences, you can do so, but they are not absolutely necessary. For you guys on the East Coast, put your local time, but make sure you specify the time zone. So you will put, you'll put 2011 EDT or 2011 UTC -4 or 2011 GMT -4. We'll get to all that later. You guys should not be marking anything on your logs yet. If you do mark stuff, we'll go over how to cross that out in the next couple slides. So one thing is, please write legibly. I do not want to be reading chicken scratch. The people back at Mission Base, when they're going through your logs, they do not want to be reading something illegible. We can see there are examples of A, B, C, and D right here. Do not write like how A writes. B is marginal at best. I can barely tell what they're trying to write. C is a little easier, but it's still difficult. And D is actually fairly okay for writing. Now, I do have a joke right here about doctors' handwriting. Just take a moment to look over that. Doctors, of course, have a reputation for writing in a way that people can't read. But of course, I'm not saying all doctors do that or anything like that. So just, I do not want to be reading any of these 6 types of handwriting on any log. Here's another joke about bad handwriting. Again, just don't do it, then you'll be made fun of like that. So there's some other things to note. If you make a mistake on a log, you do not want to absolutely obliterate it on your paper. Do not make circles, do not do anything like that. Just make a single line through the mistake, so people can see what you wrote before and what you corrected it to. One thing to note is that you should initial the correction so people know who made that correction. In this slide, it said that you should write the correction nearby, but if you do not have room to write the correction, you can draw a little number and include the correction in a footnote. So that is another way. You do not necessarily have to date it, but it is also not a bad practice if you want to do that. So some of the forms that we will be using. This is a CAP form 109. It is the ground team log, and mainly the ground team leader will be handling this form, but there are other circumstances. If the ground team leader is too busy, they can hand it off to someone else to write it. this is all the information that you need for a ground team. So you got team members, objectives, or the assignment that you're trying to complete, the vehicle, weather conditions, and radio call signs that you'll be using. Now, the CAP Form 110, this is what everyone should have in front of you right now. It's the communications log, but you can use it more like a general log as well. These are used to log communications and notable events, and we'll go over how to fill this one out in a moment. The other form that you will see a lot is the activity log, ICS 214. This is a standard form across FEMA. So under the incident command system, the 214 form can be used by pretty much any agency who subscribes to the FEMA model of handling incidents. So it is similar to the CAP Form 109, but also the CAP Form 110. It's used within CAP and by other agencies and can be kept for each individual. So as a communications unit leader, in a different situation, when I'm wearing a different hat, I will actually keep one of these for my unit. So I can have every resource or every person assigned to the comms unit listed under the names. But if I'm just going out on a ground team, I can also keep one of these logs just so that I can note notable events. Logs are never a bad idea. So for your logs, start by filling out in pen all of this information. You got 20T5083, ground team 6 as your station functional designator or location. The date is 13 July 2020 or 2020-07-13, however you want to write that. And the designator source is Google Meets. One note about the Google Meet designator source is that's the manner of how you're talking. So right now we're talking over Google Meets. That's what you're putting in the box. But if your team is using CC1P and R41P, you can note those down in boxes A and B. And anytime you receive a communication on CC1P, you just write down A in the channel ref column. And anytime you receive communication or transmit communication on R41P, you note down B in the channel reference column. So I'll give you guys a couple seconds to do that, and I will go over things in the chat. So if there are questions on, can we do it in pencil? Preferably you do it in pen. That is why we cross things out. That's why we even go over that. That makes sure, that ensures that you can't go back or someone else can't go back and change something that you wrote. So when you're signing checks, when you're signing legal documents, you always want to use pen, likewise for your logs. For correcting someone else's writing, that is why you initial it. So if you correct someone else's writing, just put your initials down and make sure you notify that person as well that you corrected their writing. Ditto marks for channel reference. I mean, just write the actual letter. So if it's CC, in the example, if it's CC1P, just write an A. If it's R41P, just write a B. It's not much more work to.
Felix, let me say something too. Also, especially on a ground team, you may not be able to get out on a radio. So one of those designator you could put in cell phone. So if you're keeping a log of your communication, even if it's through a cell phone out in the field.
Yes, thank you, sir. Was ground team 6 supposed to be written in all capital letters? Whatever is clearest for you. So it does not have to be, but sometimes it makes it easier. So throughout this lesson tonight, we'll be going through your logs and you'll be noting down different things. And I will always denote that by red text and underline. So we want you to log a multitude of things. Anytime we start or complete a task, I will remind you of this. Anytime you ask a question or enter something in the chat and what response we give to you, you should log that. It's only for you. So if someone else asks a question, you do not have to log that down. We will also have a couple slides telling you to log something specific. Some of them will go through scenarios or have other injects. So just look out for those. And for the call box, just use base. usually you put something like mission base or another ground team or another aircraft. You'll see ground team 2, cap 1171 for an aircraft, stuff like that. So we will be proceeding through the lesson and you'll be logging things in this format. So I have an example right here, and I actually want you to log this one just for practice. This should be your first entry in your log, and this is what you'll log. Now, at the time, I just have 1900 CDT. Put whatever time it is now and put your local time zone. So for you guys in Illinois and Central Time, that'll be 1921 CDT, and the rest should be the same. So give you guys a couple more seconds to log that. Please be expeditious, but neat. I want to be able to read it. All right, so we'll have another practice log entry just to get you guys on the roll. If you already wrote 1920 CDT, that is fine. So this one, again, put your local time right here. This is just an example. So for you guys writing it right now, just put 1921 or your local time. So this is the scenario. You have just departed the staging area and you reported the time to mission base. So this is an example of what you can log in your log. It doesn't have to be verbatim exactly as my screenshot shows, but you need to be able to get the message across. All right. So questions, any questions, please keep asking them. Otherwise, throw the task number, your name and your cap ID into the chat. Yes, I can go back. Any questions on logs? You can unmute and ask.
Yes, what did you want in channel reference?
So in channel reference, it is whatever channel we're talking on. So currently we're talking over Google Meets. So in that box up top, under designator source, you'll put Google Meets in the A box, and then under channel reference, you just put A whenever that's what you're talking on.
Thank you.
All right, so everyone should have been able to log that, and we'll start moving on to the next task. So we're going to start off by going over our favorite topic right here, our grid, true, and magnetic north azimuths. Please log this in your logs that we started the convert between grid, true, and magnetic north task. Give you guys a couple more seconds. And please ignore the little heading in the middle or this middle section right here. This was a copy and paste error in my slideshow. So we will review degrees, minutes, and seconds. So when doing math with degrees, we want to think of it like a clock. So what if we want to add an hour and 36 minutes to 12 o'clock? We get 13:36 or 1:36 p.m. Similarly, we can add degrees, minutes, and seconds, or just degrees and minutes in this case, to in the same way. So if you want to add 1 minute or 1 degree 36 minutes to 12 degrees, we get 13 degrees 36 minutes. You can see on the right side, every degree has 60 minutes and every minute has 60 seconds. So it is very similar to a clock, except the hours in this case are degrees. So here's another example. If you want to find 3 hours and 29 minutes before 2:03 p.m., you basically subtract 3 hours, 29 minutes. So similarly, if you have 14 degrees and 3 minutes, and you want to subtract 3 degrees, 29 minutes, you will get 10 degrees, 34 minutes. Any questions on that? All right. So we'll start by going over some of the quiz results from last time. This is from 0213. And most of the errors that we saw were because you guys went in the wrong direction. So when we had an east magnetic declination, you guys added instead of subtracted. And when we had a west one, you guys subtracted instead of added. A lot of you got 7 out of 8. Some of that was because you missed the none of the above answer choice. We had one choice in there that was 10 degrees off of the actual answer, and some of you missed that. And some of you just selected the wrong answer altogether. So make sure you pay attention to questions like that. It's an easy mistake to make, but on a search, you really can't afford to make that error. And the review, I guess the review item is you got to remember east is least, west is best. So when the heading you're trying to convert to is east, then you subtract the difference. So if you have a true north heading and you have a magnetic declination that's east and you're converting from true north to magnetic north, you want to subtract the difference. If the magnetic heading is west or of true north, then you add the difference. And the same applies for converting from grid to true, true to grid, grid to magnetic, all those types of things. So we'll go over some of the questions in the quiz just so that you guys can see the process for getting to the correct answers. So for 90 degrees true north, you want to find magnetic north and grid north. So starting off with magnetic north, we notice on the declination diagram that magnetic north is to the east of true north. So we know we need to subtract. So 90 minus 7 degrees, 59 minutes is 82 degrees, 1 minute. Similarly, if you want to find grid north, you also want to subtract since it is to the east of true north. We can apply the same principles to convert from magnetic north to true north. So true north, we know, is to the west of magnetic north. You're going to the left, which means you have to add the magnetic declination. And then in a similar manner, for 90 degrees grid north, and you want to find true north, you also want to add. Now, the second diagram on the quiz went over pretty much the same process. We saw that magnetic north is to the east of true north, so you want to subtract. The difference is grid north is now to the west of true north, so now you need to add that difference. For converting magnetic north to true north, we notice that true north is to the west of magnetic north, so we need to add the declination. And then for converting grid north to true north, we notice that true north is to the east of grid north, so we need to subtract the difference. So any questions on those review or any questions on those previous questions? So for round 2 of the quiz, if you did not pass the quiz the first time, you should take the second version. We wrote a completely different version of the quiz using different declination diagrams. It is not a retake format, so you can only take that one once. If you fail that one again, then we will have retakes available for you to complete multiple times. The format of the
Everybody
quiz...
speak. Hold on 1 second, Felix, because I felt bad that a lot of people did, and I sometimes still get confused, and I've been doing this 35 years. If anyone has any questions, make sure you ask them now.
Okay, no questions. So yes, going on. The quiz round 2, the first 6 questions are designed to help you work through the problem. So we will have multiple choice answers for you to choose from, but some of them will be obviously wrong or just not very good options, and you'll be able to see that when we release the answer. So after you answer those first 6 questions, please use those as a guide for your thinking process as you answer the next 6 questions. So those will be more on your own, but I still cover, or I still give you a couple of hints on some of those questions. As Lieutenant Mangiello said, there are plenty of YouTube resources out there. I have actually linked a video in the course handout, and if you just search on YouTube, you'll be able to find plenty of resources. So here is some more review. And pay attention to this review because this diagram exactly shows up on the quiz. So if we had a heading of 123 degrees, 45 minutes true north, and we want to find magnetic north and grid north, first we look at the declination diagram and we notice that magnetic north is to the east of true north. So we do 123 degrees, 45 minutes minus 16 degrees, 30 minutes, and we end up with an answer of 107 degrees, 15 minutes. Similarly, if we want to find grid north, it is also to the east. So again, east is least, west is best. You're going to subtract the difference of 1 degree, 10 minutes from 123 degrees, 45 seconds, or sorry, 123 degrees, 45 minutes. If you're given 123 degrees, 45 minutes magnetic north and you want to find the true north, you are going to follow the same process. True north is to the west of magnetic north. So now you are going to add the declination of 16 degrees, 30 minutes and end up with an answer of 140 degrees, 15 minutes. And similarly, for converting grid north to true north, it is west difference. So you will need to add 1 degree, 10 minutes for an answer of 124 degrees, 55 minutes. Any questions on that? So at this point, please log that you were present for task 0213. Make sure you include your name and cap ID in there. And don't forget to put in your form 110 that you entered the completion of 0213 into the chat. Any questions? Speak up now. We will attempt to work through these together so that all of you guys can hopefully pass them the first time. For the zero, I saw a question about writing a zero in a certain way. As long as you're clear about it and you can distinguish between your zeros and your O's, I am not going to be super picky about putting a slash through the zero, but the formal way to write the zero is you put a slash through it to differentiate that between a zero and an O. Wait for a couple more seconds for people to get their names and the task number in the chat and to log everything down. All right, so now we're going to start the next task, which is measuring distance on a map. So here's another log entry that you got to make. We started the measure distance task at 6:35 for me, 7:35 for some of y'all, and on the East Coast, 8:35. The objective of this task is, given a map and a ruler, compass, string, whatever, how do you find the distance between 2 points on a map? So, background on measuring distance. So there are different types of distances. There's a straight line distance. If you're walking cross country, right, if you're cutting straight through a forest or straight through a prairie, you will be taking a straight line path. You can also take a curved path on a road or a trail or something else. So, of course, if you put bends in the path that you take, it'll take you, or it'll be a longer distance between the 2 points that you're moving between. The task guide says that the distance for mounted travel should be determined in miles, since your car odometer is in miles. Your distance in walking should be determined in meters, so you can use your pace count. We are not going to go over pace counts during this ground team training session or series, but that is something that you'll have to figure out and know for later ground team training. If you need to convert between meters or kilometers and miles, you can use the 0.62 miles in a kilometer or 1,600 meters in a mile. You'll also notice that all topographical maps are drawn to scale. So we talked about this last time. There can be a scale of 1 to 24,000, 1 to 62,500, and things like that. These scales mean that 1 millimeter of map distance equals 24,000 millimeters or 24 meters ground distance for that 1 to 24,000 map. And the USGS quadrangles use the 1 to 24,000 scale. We can use various methods to measure distance on a map. Whatever method is accurate and most appropriate should be used. So you can use a straight edge ruler. The sides of some compasses will also have rulers. You can use a map tool. You can use a piece of string or a wire or anything that you can use. And the objective of these things is you just get a distance between those 2 points, and then you can compare that to the scale that should be included on your map. So we got a couple examples that we can go through. So for a ruler on the side of a compass, this is a military style compass, and the scale is 1 to 50,000 meters as listed right here. This scale is useful for the MGRS, the Military Grid Reference System, and usually those maps are in scales of 1 to 50,000 or 1 to 25,000. So you can actually compare each tick mark on this compass to a ground distance that you know. You can't use this on the quadrangles because those are usually 1 to 24,000. At least you can't use it directly. You can still take the distance down or note the distance and compare it to the scale on the bottom of the map, but you cannot use the little tick marks for directly measuring distance. There are also some tools, MGRS and metric tools. So these compasses are really nice. You can usually get or these protractors are really nice. You can usually get them in a clear format, so you can just slap it over your map and center the point that you want to work off of. And you can find the angle measurements in mils and degrees around the outer side or the outer ring. And you can also see that we have different scales here. So 1 to 25,000, 1 to 50,000, and 1 to 100,000 here. And depending on the scale of the map you use, you can use that to find the distance between 2 points. So here is a ruler in action. We know that for this VFR sectional, it is scaled at 1 to 500,000, which means that for every centimeter, the actual distance is 5 kilometers. So if we want to find the distance between Wendover Airport and the Bonneville VOR, we see that it's about 4.45 centimeters on the ruler, and every centimeter being 1 kilometer or 5 kilometers, we multiply those two together and we get 22.25 kilometers for the distance between Wendover Airport, or the center of Wendover Airport, and the Bonneville VOR. So here's some common map scales, and you might be wondering why we have some weird numbers. So the 1 to 500,000 scale means that 1 centimeter on the map is 5 kilometers. And the way we know that is 1 centimeter is 0.01 meters. 0.01 meters times the scale of 500,000 means that you get 5,000 meters out of that, and 5,000 meters is equal to 5 kilometers. There's some other scales, such as 1 to 25,000. So 1 centimeter on the map is equal to 250 meters, or 0.25 kilometers. You also have the USGS quadrangle, the 7.5 minute quadrangles. Those are usually 1 to 24,000, which means 1 inch is 2,000 feet. And if you see 1 to 63,360, that is because it's 1 inch to 1 statute mile. And because of our nice, wonderful units where we have 5,280 feet in a mile and 12 inches in a foot, that's why we get these weird numbers. So another method of measuring distance, you can see in this picture, or in these two pictures, that the person is trying to find the distance along that what looks like a road or a trail. If you look at the key, it probably is the boundary of a camp or something like that. And basically, you use the string, you can use a wire, you can use whatever bends to follow the path that you need to take, and then you can compare that to the scale on the bottom of the map. So you guys will need to be using that technique on some of your quizzes, or at least this quiz, to measure the distance between 2 points. Here's an alternate method. We will actually not be covering this method, or at least not forcing you to use this method on the quiz, but we will test the information in here. So remember from last week that each minute of latitude or longitude is equal to 1 nautical mile. So in the picture below, you can see that this spans 30 seconds, or half a minute. You can see that it starts at 112 degrees 15 minutes and goes to 112 degrees 30 seconds. So we know that is half a minute, or roughly half a nautical mile, or 0.575 actual miles. So always remember to verify it with the map scale. Using any one of these methods, you can always pull it down to the map scale, and that will give you the correct distance. So on the quiz, we will have a map scale included with every picture. And the way the pictures are created is that no matter how big or how small your screen size is, the scale will size proportionally. So that is not a factor in if you get a wrong answer. You just reference with the scale and you'll do fine. Any questions on this task? As the slide says, please enter O-0212, your name and cap ID into the chat, and make sure you log on your form 110 that you entered the completion of this task into the chat.
Can you go back a slide? I want to mention something to them. Okay, so this is obviously the scales on the bottom of a lot of different maps and things. The only thing I'm going to say is, if you're going to be working with some other people, like other ground teams or whatever, please ensure you are using the same measurements. Because it's happened before in missions. So make sure you all agree before you leave which one you're actually going to go off of. Yeah, because it's happened and things got a little messed up. So.
Mm-hmm.
Yeah.
And along the same lines, this is less of an issue now, but there's also this issue of datum. So if you're using latitude and longitude, the datum has to do with how those latitude and longitude lines are spaced out and represented on your map. So you'll see this one is NAD, or North American Vertical Datum of 1988. You'll see a bunch of different things like WGS 84, NAD 83, all these different data. And just make sure that your maps are working off of the same things, because a latitude longitude coordinate using one datum is not going to be the same as another datum. So at this point, all of you should have logged the completion of this task in the chat and on your 110s. So any questions before we move forward?
Yes, sir. Just one. When you talk about datum, is that the same as what they use as projections in the GIS world?
Yes, you can compare it to the projections, although projections have to do more with how the map is kind of flattened out. So at least in my understanding, is the projection is how do you turn our Earth's sphere into a flat map, and the datum has to actually do with the latitude and longitude locations.
I have a question.
Yeah.
Sorry.
Yeah, go ahead, ma'am.
I have a question. I entered my last task late. It was typed in, but I didn't enter it, but I wrote it down in my log. So I have an error, a discrepancy between time.
Okay. So just put a single line through the time
correct it.
and initial by the correct time.
Okay, but now my log's going to be all messed up because my next log was entered correctly. Oh my god.
That's fine. Just leave it like that.
Okay, just leave it like that. All right, thank you.
Yep, and that also highlights why we want to do the single line strike through, because then we can see perhaps why it is out of order instead of it just appearing as something random.
Okay.
So, all right, so we have a log entry inject. The scenario is that you have arrived in grid and you are starting the search at this time. So log that however you feel fit in your logs, and we will move on after a couple seconds. All right, now we are going to move into the task for plotting azimuths. Again, please log this down that you started the determine and plot an azimuth task. And the goal of this task is, given a map and a point, how do we plot an azimuth? And as a reminder, an azimuth is basically a heading. So I'm standing at this intersection, and what direction is let's see. All right, what direction is north, or what direction is 20 degrees, or what direction is 180 degrees? Okay, so I see the it was producing a loud buzzing sound for me, so that's why I muted you. But yes, I can go back. Is this the slide you were looking for? Okay. Awesome. So how do we plot azimuths? It's actually not too hard. So the ground team task guide says in some situations, a team might be given an azimuth to plot. A good example would be if another ground team has determined the bearing to a distress beacon from their location. Plotting this azimuth on your map could help with the search. And you'll be plotting azimuths when you're doing triangulation of ELTs. That is a task that we're not covering, but all of these integrate together very well. So the 4 steps that they mention are that you should first plot the point on the map. So where you currently are, or where the location is that you need to be plotting the azimuth from. Then you want to ensure that the azimuth you're trying to plot is a grid and not a magnetic azimuth. If you got a magnetic azimuth, for example, you got the azimuth from your compass, then you need to convert it to a grid azimuth before plotting it on the map. In Illinois, that is not such a big deal because the declination should not be that big. But out here in Colorado and out east, the difference will be 10, 12, 20 degrees. So that is very important. You want to place the protractor on the point with the 0 degree mark oriented to grid north. Place a pencil mark at that degree mark on the protractor corresponding to the azimuth, and with a straight edge, you want to draw the line from the first point through the mark you just made. All right, I get that that is very confusing. So some pictures. I saw the question, if you run out of space on the remarks line, do you go to the next line? Yep, just feel free to do that, but make sure to make it clear that it is from the previous entry. So, plot an azimuth of 123 degrees grid north from Raspberry Butte. So first we want to identify the point on the map and put our protractor over that point. So Raspberry Butte is right here in the center of this protractor. We want to align the protractor with the grid north, and this is signified by these orange lines right here. So using this X or the cross right here, as long as the 2 lines are parallel or parallel enough, you can consider that aligned with grid north. Then we want to identify 123 degrees on the protractor. I know it's hard to see, but that's this line over here. And 123 degrees, you can mark that. On these, the degree is in the center of all this stuff, so you can use a straight edge, line it up with the center and the 123 degree mark and make your marks. In this case, I made 2 marks, but either of the red points can work. Then you take the protractor away, use your straight edge, and draw a line from Raspberry Butte through one or both of the points that you marked, and they should all line up. So question on, should we leave the time channel reference blank? Yeah, just leave it blank if you're overflowing to the next line. So for you pilots out there, this might make you happy, because if you want to plot an azimuth from a VOR, it is actually very easy. You don't even need to use a compass or a protractor to do that. For those of you who don't know why this might show you. So around a VOR, which is a navigation aid for pilots, there will always be this little compass that shows which way is magnetic north. That's the 0 degree heading right here, and everything else around it. So to identify 321 degrees from the VOR, it is actually very easy. You just find 300 right here. It's marked in tens of degrees. You move up to 310, 320, and then find 321. You draw a line, and there is your azimuth of 321 degrees from the Hanksville VOR. Any questions on that? That's pretty straightforward. And you guys will be asked to do some of these tasks on your quiz. Keep in mind, sometimes we will give you different things. So we won't always give you the protractor. We won't always give you something to reference off of. Sometimes you just have to know, hey, if 0 degrees is north, then 180 degrees is south. And anything between 0 and 180 degrees is going to be east, and anything between 180 degrees and 360 degrees is west. So some of those questions will make you think a little bit on the quiz. Also, don't forget to log that you completed 00214 into the chat, or you entered that into the chat. Don't forget to log that. Cool. Don't know if you guys can all hear it, but there's basic training going on in the background and people are marching around. So here's the next log entry inject. You have just checked in with mission base and you just reported to them ops normal or operations normal. So write that down on your log forms. And one strategy is, if you find that sometimes you're missing some of the information, go write down the actual message first and then go back and fill in the time and the channel reference and who you called, because it is a lot more important to log down what it was that you communicated rather than when you did it or who you did it with. Of course, those are important, but the message is first. So now we will move into orienting a map using terrain association. So basically the task goes over, if you're given a map, how do you orient it to the ground using terrain? And terrain, by terrain we mean, buildings and roads and stuff like that too, because those will also be marked on the map for this task. Don't forget to log that you started the orient a map using terrain associations task at this time. All right. So if you guys were here last week, you might remember these slides where we gave you a view to your left, in front, and to your right, and we asked you to identify where you were on the map. This task is very similar to that format. So, hey, we got a log entry inject. You have just blown a tire, and you report that you are at mile marker 13 of I-80 to mission base. They tell you to pull over, change the tire to the spare, and return to base immediately. Yes, I can go back. I'll just stay on this slide for a little bit longer so that people can get that down, and then I'll move back for a little bit. And part of the logging task is that, hey, you need to be able to remember what is being thrown at you and log it down. Because after you make that radio call and mission base responds, or after mission base gives you an instruction and you confirm it with them, sometimes you just have to remember what they said. So get into the habit of capturing all the key information, maybe write down the keywords, fill in the information later.
For those of you who haven't kept a log, if you're on a ground team, to return to base, abbreviate RTB. You don't have to write it out. All you have to do down is RTB.
So I'll assume that most of you have got that. I'll come back to this, but there's a request to go back to, was it this slide? Yeah, I'm back at the original slide. I think I had a request to go back there. Okay, So finish logging this down. Blown a tire, mile marker 13 of I-80. Change the tire, return to base. We have a mention in the chat that shorthand is great. Shorthand is indeed great, but make sure other people can understand your shorthand. All right, so here is a task. We want to orient this satellite image, or this map, in accordance with the satellite image, so that the direction we're facing, which we'll call the top of the slide, will be the top of our map. So this is interesting. You see that this is Lake Mead over by Las Vegas. We have an aviation sectional on the right and a satellite image on the left. What you want to do is you want to make note of some notable features. We have this little triangle shaped thing marked in blue, and there's only one tip of the lake where it roughly looks like a triangle. So you mark that on your map. You notice there's a ridge line here in orange, and those are the Muddy Mountains. You also notice that near the center of the lake, there's a little offshoot, and that only happens on one side, and that's the box in red. And then you notice that one of the, I guess, 3 legs of the lake has things feeding into it, and that's marked in magenta. So you make a note of all these things, and then all you have to do is flip the map so that the orientation of everything matches. So I just turned this sectional 90 degrees clockwise, and now everything matches up to the orientation that we're looking at. And this red box shows roughly the area that the satellite picture shows. Now here is another example. This is out in Illinois, in the Naperville area. You are given a map and you know your location. You're at the Green Valley Scenic Overlook. Now to the front, you see this view. You see some water over here, what looks like a quarry or something. To the right and behind you, you see a road leading away from you. And at your left and going towards the rear, you see a ridge and some other hills. So we plot those on the map, and we can see that, hey, we saw water in the front. We saw a road leading away. That's this road over here, if you can see the laser pointer. And then over here, there's some other various hills which kind of form a ridge line to your back left. So now that you have all those plotted on your map, you can rotate the map to the correct orientation, and boom, now your map is oriented to the ground. I had a question for, let's see, what they mean by triangulation. Triangulation is a little bit different. So triangulation, basically you move yourself to 3 different points or 2 different points or however many different points, and you plot azimuths on the map. And where they intersect, where those azimuths intersect, is the point that you're trying to go towards. So you can do this with cell towers, you can do this with ELTs and beacons and stuff like that, but we're not covering that in this ground team series. Now, sometimes you may have some obstructions. So I hiked up to a local mountain peak on a cloudy day, and I got on top of the clouds. I can only see a bunch of mountains, and the clouds are covering the rest of everything else. Now, there's no way I'm going to be able to distinguish these various peaks on the map individually because there are way too many individual peaks. But we can guess that the clouds are lying in the lower elevations, or at least where the ground is at a lower elevation. And we know that to the left side, it is an area that's higher. You can see all the mountains, they're free of clouds, and you can kind of see a series of peaks moving down the center. kind of varying to the right. So given this terrain map and the information that we are on Eagles Peak right now, we can see that, ooh, okay, there is a big line of mountains running up and down the center, and to the left, it's all at higher elevations than to the right. So we can guess that, oh, okay, we have mountains and high elevations to the left and the clouds and the lower elevations to the right. We are actually already, or the map is already oriented to our view. Here's another strategy that you can use. So this is a picture I took at 7:53 in the morning, and the only information that I have is in front of me, 7:53 in the morning. You can kind of identify which way I'm facing based on this picture, because we know the sun rises in the east and sets in the west, so your shadow in the morning is going to go towards the west. So you can see my shadow right here, and I think my dad right there to the right of me is facing towards the west. And we know from this trail map right here, the sun is behind us, I'm standing right here, and we're facing towards the west. All you have to do is turn that map 90 degrees to clockwise, and now it is oriented to your direction. Any questions on that? So make sure you enter task O-0216 into the chat and log that on your Form 110s. And we are, like last time, blazing through the material. So no breaks for now. I think there are a total of 95 slides, and we are 78 slides through. But of course, if you guys have questions, please, please, please ask them, rather than doing not so well on a quiz and having to spend your time and my time on retakes and stuff like that.
Hey, Cadet, we had a couple people come in late. Before we start with the some more slides, can you go to the beginning so they know how to fill out that 110?
Yes, I can go back to the beginning.
Okay, thank you.
So yeah, for you guys who came in late, at the top of your log, please fill in the information as it is shown here. Mission number is 20 Tango 5083. Your ground team 6. Date is today. And the source of everything that we're doing today is Google Meets.
And Cadet Zhang, did you guys switch the link that we used to have? Because I clicked on it earlier tonight, and where you can see the test results and the old background or the old layout, it's completely different. It's like an answer sheet to tests. So I was just wondering, did you guys change that link?
Like the student tracker?
Yeah, that one where it had all the information like week 1, week 2, week 3. It's when I click that link, it's something completely different that came up.
Oh, you mean the course handout?
It's where you had pretty much where it was week 1 and we did what we did and where we, yeah.
This one?
That's the one, yeah, that's the one I was looking for, but before tonight. But when I clicked the original link, it came to something completely different.
Okay, I will type a short link into the chat.
Okay, thanks, I appreciate it. I don't know why the other link is sending me somewhere else, but yeah, thank you.
Yep. All right, so for those of you who came in late, I hope you got all the information here. These slides are available so you can go back and look at these later as well. We'll keep chugging on for the rest of the group. So here's our last slide, 78, and now we have a log entry inject. The scenario is that after your blown tire and the instructions to return to base, you have arrived and will proceed to debrief, and you told this to mission base. So this should be relatively straightforward, so we'll just move on. And again, these slides are available. So a couple things. That was the last task of the day, and we'll just go over some quiz feedback from all the day 3 or the week 3 quizzes. So one thing that we noted was that many of you missed answers on this terrain or this elevation quiz. So the most common mistake was that you selected C as being 9,020 feet. You can see that C is 1.5 contour lines up from 9,000, and you know that there's a 40-foot interval for each of the contour lines. So if it's 1.5 contour lines up, we're actually 60 feet up from 9,000, and you get 9,060 feet. In this case, 9,020 feet was the option that wasn't labeled, so that was the not labeled option on the quiz. Oh, here is a log entry inject. During the debrief, you realize you marked the mile marker incorrectly, but you communicated the correct marker over the radio. Instead of mile marker 13 of I-80, it was actually mile mark 17. You must correct the error from the previous entry. So again, you reported it over the radio correctly, but you wrote it down incorrectly. So I gave a little example in the upper right corner of how you can correct that. So 13 changes to 17. All right, more quiz feedback. We had a lot of confusion on this one as well. This asked you to, I think, identify which one was a depression, a hill, a ridge, and a valley. And you were given the options A, B, C, and not labeled. A lot of you guys said C is a ridge. And there are a couple of hints that we can use to tell that C is not a ridge. C is actually at a valley. So the first one is what we mentioned from last week, but perhaps maybe not diagrammed as clearly as we would have liked, but now is diagrammed here, is that on terrain maps, you'll notice that there are V's or something, things that look like V's. When the V points uphill, then it is a valley. And when the V points downhill, it is a ridge. So you can see in this case, the ridge is signified by these magenta lines. And then the valley is signified by these blue lines right here. So I'm tracking the questions in the chat. Just stick around after the meeting and we can go back to those. And here's another hint that was a valley. So in this map, unfortunately, it's black and white, and I guess there's brown in there too. But usually a valley will have a stream in it, or actually vice versa. Anytime you see a stream or a creek or some sort of water, it will lie in a valley. So unfortunately for this map, it wasn't in blue, but if it was, you can tell that very easily. For future reference, the 3 dots and a big line in this format, that is a river, stream, creek, something like that. So that's another hint that you can use to tell that C is a valley. And for those of you who already attempted the retakes, you know that I really drilled down on valleys versus ridges. I think I labeled A through Q on a map and and you had to get every one of those correct as either a ridge or a valley. So luckily that map was colored. And some stuff from me. So we got a problem with people submitting quizzes well past the deadline. I was tracking multiple submissions of day 2 quizzes, or week 2, that was 2 weeks ago, even after the day 3 due date. And I had more than 50 submissions, or 50 different quiz submissions after the deadline, after the 0100 CDT deadline this Saturday. So please follow the posted deadlines. We have been nice thus far, and we know that you guys are pouring a lot of time into this class. We appreciate that, but it is getting a little annoying that I have to keep on going back to previous weeks for new quizzes. So just keep in mind the day 4 quizzes are due at 0100 or 1 a.m. CDT on Saturday this week. Oops. Now, we are always willing to work with you. So if you got a unique situation, if you're out of town, if you got, something else going on, that's fine. Just send us an email and we'll work it out. But you see that number of over 50? I wrote that number 2 days ago or 2 nights ago. So that has definitely increased since then. All right. Any more questions on anything here that the entire group should hear? And please don't forget to log that you were presented quiz feedback on your Form 110. We got a couple more slides after this, but any more general questions? I see, yeah, the retakes are not due by then. So I have all the retakes for this week. They're already posted. The quizzes, I actually already have them written up and they're ready to paste into the document. So I will get those done shortly after the meeting ends, so you guys can take the quizzes. And then everything else, the retakes will come out after the deadline on Saturday, and we'll move forward from there. And of course, if you have any questions, just let me know. So, all right, here is your final log entry. Do not make the log entry yet. Log the time you log off from Google Meet. So when you hit that hang up button, log that time. At the top, you notice that there's a page 1 of something. Make sure you mark the total number of pages at the top. For most of you, that should just be 1 page. And to submit logs, please scan them or take a picture of them and just email them to me. At this point, if you're here for the entire time, you should have a minimum of 15 entries and 1 correction in your log. Please scan or neatly photograph these things. If you're using your phone, there's some good apps that you can use to scan things. And these will crop out extra stuff, convert them into PDFs, and do all sorts of fancy things. So you can explore some of these apps to do so. So that makes my life a little bit easier.
Cadet Zangs, I'm asking everyone, do not log off when he's done with the slide presentation. I got a couple things I want to say.
All right.
Now finish up your slides because I'd like to see if I can get get the slides down.
Okay. So this being the last lesson, there are some next steps that we would like you to take or to verify. So this is the course handout. It's the same document that we've been referencing the entire time. And there, at the second to last page, there are next step instructions. Stuff that I want to emphasize. If you have unresolved absences, or if you are absent and you would like to make up a lesson, please let me know, and we can work with you to make sure you get signed off on particular tasks. Again, the quizzes are due at 0100 at 1 a.m. Central Time on Saturday. Remediation quizzes for day 3 topics are posted. They're at the last page of the course handout. Remediation quizzes for day 4 topics will be posted around, I said next Monday here, but more likely around Saturday or Sunday when the majority of quizzes are complete. And please complete all the requirements sooner than later. So, while I will take remediation, in September, I really don't want to be doing that. So if you need to retake a quiz, please get that done as soon as you can. And here's my last slide. Thank you for participating. If you have feedback on the course, questions, improvements, suggestions, anything like that, if you want to talk to me more about my experiences in emergency services at the Academy, anywhere like that, I am open for all those questions, and I'm sure Colonel Taylor is also open to talk to people about his experiences and other information like that. And please don't leave yet. Colonel Taylor has some stuff he wants to add.
Okay, I'd like put the slides down so I can see everybody.
All right.
Okay, great. I can't see everyone. We got 46 people signed in. First of all, I'd like to thank everyone for participating. I hope this was educational. And as I said at the beginning, we at first thought it was going to be Illinois Wing, and we have people from all over, Texas, Florida, Maryland, you name it. I have to thank Cadet Zangs. Colonel 30 Acres wanted to ask for a volunteer. For those of you who don't know me, I've got 35 years in Civil Air Patrol, and I used to be the ES officer, now I'm the transportation officer for Illinois Wing. But I have been at NASA for 20 years. I used to be in the field, so that's why I volunteered for this. But I do have to thank, I got an email from Cadet Zangs. He was up in Utah, Salt Lake City. Where were you at, Felix?
Yes, sir. Salt Lake City area.
Yeah, he was with his family, spending some time with that. And then he was en route back to the Air Force Academy. He is going to be a junior this year. That's why I'm shaking my head. He's got to start studying so he can become an Air Force officer. But don't turn it on, but let's give Cadet Zangs without him, I could not have done this. He helped me with all the computer, setting all this up. I could not have done all this background. I'm not that smart. Are there any questions from anyone? You can turn on, and if you have anything or any comments. Okay, let's see. Okay, if you have any questions, if you came in late and you want something answered, stay on. We'll stick around. For those of you who got all this, you want to go start taking your tests, go ahead. And have a good night. Been nice meeting all of you.